All right, we have a question here which is looking at a collision, and we're thinking about loss in kinetic energy. Okay, have a go at the question, and then when you're ready to see the answer, keep watching and we'll see what we can do to explain how this works. Okay, so in this question, I think the first thing to acknowledge is that we're dealing with an inelastic collision. Okay, a lot of students get a little bit worried at this kind of stage. We're looking at inelastic collisions, so we can't do anything about conservation of kinetic energy. However, what we can use is the conservation of momentum. The conservation of momentum always holds. In other words, we can always use this equation. Okay, providing we have no external forces, so no gravity, no friction, no air resistance, no electromagnetic forces, etc., we can use this equation. What this says to me here is the mass 1 times initial velocity of 1, and the same for 2, added together is equal to the product of the masses and velocities after the collision. Now we're going to simplify this a little bit more, okay, because we've got a few things we can do here. We know we've got a mass m which is moving, and we have a stationary ball of mass 3m which is not moving. Okay, so that means that this whole thing simplifies a little bit more. On the left-hand side, this term is going to be 0 because the initial speed of this 3m is 0. And we're going to call that initial speed u. So we've got m times u is equal to the final momentum. Now this time, the two balls move together, so they're both going to have the same velocity. M times v is equal to 3m, plus 3mv is equal to 4mv. What does that mean then? We can simplify that out to find that the final velocity of these guys, when they stick together, is a quarter of the initial velocity. Now that's why we're losing kinetic energy, because we're slowing down and therefore the kinetic energy is decreasing. Now this question is kind of tricky because we're then saying what's the percentage loss? You will notice lots of these kind of questions and they're trying to find different ways of asking the same thing. We're really looking at sort of the non-conservation of the kinetic energy in this case. So if we then go for that, the initial kinetic energy is just going to be a half mu squared because we initially had a mass m traveling at speed u. The final kinetic energy is going to be a half of the final mass, which is 4m, that's that 3m plus m, and then we're going to take that u over 4 and we're going to square it because that's our velocity, final velocity squared. We're then going to take the ratio, we're going to take the loss of these things, okay? The percentage lost is going to be the difference divided by the initial value. Okay, now if you put those numbers, I've simplified it here, if you put those numbers in, we're going to get a 1 over minus 4 over 16, that's 0.25, which comes out as a 75% loss of kinetic energy in this system.